Hello everyone, in this video I'm going to go over how to solve this problem on the professor's YouTube video called Two-Port Circuit Practice 2, where he comes up with this set of equations, and I'm just going to show you how to solve the set of equations using a matrix. And if you want to see where these equations come from, you can go back and watch his video. In order to solve a system of equations using matrices, this is the basic steps of what you have to do. First, you have to manipulate your equation set and put all of the variables on one side equal to all of the constants. And then you set up this basic matrix form using this formula over here, which you've gone over before. So I'm just going to take these equations and start to put them in the form that I need. So starting with this first equation here, I'm just going to move all of my variables onto the left side and all of my constants onto the right side. Now that I have all of these equations in the form of variables equal to constants, I'm going to start to set up my matrix. I'm going to be using this form right here in order to set up my matrix because I know exactly how it functions, but if you're still learning matrices, you can always write it in this form and then go back to that form. But it's a lot of writing, so I'm just going to go straight into writing in this form. And a trick that I do when I'm writing them out and there's a lot of variables, I write out my variables across the top here just so that I know what order they're going to be in when they come out. And it's basically the same as writing them in this form with this equal to your variables. I'm just writing them along the top and skipping that step. So I just take my variable coefficients and I start to fill them in. Now that the matrix is completely set up, we can go ahead and plug it into a calculator. So the first thing you have to do is select second and then this key with the matrix above it, second matrix, tab over to the edit section, and then select that first matrix in order to edit it. And in this case, for our problem, we have a 6 by 6 matrix, as you can see over here. So what we have to do is hit 6, enter 6. And then what you're going to do is just go through each row and input the exact values that we derived earlier in the video. So for this first row, we have a 0, 10, 0, 0, 1, 0. For the second row, we have 15,000, enter 0, 0, 1, 0, 0. And then for the next 4 rows of the matrix, I'm just going to input the exact same values that we came up with earlier, and I'm going to speed up the video a bit so you don't have to watch the whole thing, but you can see the process. So this here is the end of the 6 by 6 matrix, and in order to exit, you can hit second, quit. And now in order to enter our 6 by 1 matrix, you have to hit second matrix again, tab over to the edit section and then select that B matrix or whichever matrix you want to enter this in under. So here you have to change the values again, 6 by 1. And the only value we have to change is in that first row and enter that as 30, and I already have that as 30 right here, so I'm going to hit second quit. And then this is where the formula that I wrote out earlier, x equal to a raised to the negative 1 power times b, comes into play. We're just going to enter that exact formula into the calculator and it will give us the values of x. So to do that, you hit second matrix, select that first A matrix under the names section, and then raise that to the negative 1 power. And then you can multiply that by the B matrix by selecting second matrix again, and then just selecting that B matrix where we entered it, or whichever matrix you decide to enter yours under. And then you can hit enter, and this right here will give you the values of all of your variables. This right here is equal to I0, I1, I2, V0, V1, and V2. And this gives you all the answers and is a method you can use in all of your linear circuits problems.